this tool, we made a choice, conscious choice, that we'll be exposing it as a web app. So that makes a default choice that will be storing the data, all the PDFs user is uploading on the product. They will be stored by us, by the product, and that kind of brought us, responsibility upon us that we will take care of all the user data. Okay, and also the reading experience was also delegated to us, right, because of that choice. And now what happens with reading experiences, like users have strong preferences over where they want to read, let's say, right? So I'm sure that a lot of you have been reading PDFs, and you will have a pet app where you will read that, right? Be it Adobe reader, be it a default reader on your Mac or Linux, be it a web browser. So different people have different preferences when it comes to reading experience. Now, second question is like, what is the opportunity cost of developing a good reading experience for a user, right? So reading experience in itself is very evolved. It is a very old problem, and people have evolved a lot, right? Adobe has been working on it for decades, right? All the operating system, they have their reading apps which are in active development, right? So when you say that we are going to give you a reading experience, you are actually competing against them, right? So one has to think like, what is the opportunity cost of competing on the reader experience? What are you losing out, right? What other features you can build if you just didn't compete on that, right? So that is something, uh, a good question to ask. When you are building such kind of project, what is the dropout because of inadequate reading experience? Let's say you are giving very good features, right, around literature analysis, right? But your reading experience is bad. Now, most of the features are depend on how much time you spend on reading on the platform, right? Now, if your reading experience is not that adequate, then people might never reach the different features that you are building for them. Okay, so that is something about reading experience. Fifth thing is search and recommendations. Like, what is the role of good recommendations in retention, user retention? So let's say you are building a very good recommendation algorithm around literature, right? So what are the chances that you being better recommendation engine than others allows you to retain users, right? So that is another question. uh, Another question is like, are people really interested in being recommended research papers, right? To read each research paper, it's a heavy task, right? So let's say that it takes you 20 minutes to watch a YouTube video. It takes you like roughly 2 to 3 hours to actually make sense of a research paper, and that too when you are well versed in that field, right? If the research paper is out of your field, then it takes even longer. Now, when you recommend papers, you're actually kinds of equate to you're giving more homework to people. Like, do they want more homework or less homework, right? That is something from a UI or UX point of view you need to think about, right? So around search, there is another theme. Now, after the advent of retrieval augmented generation, chat GPT and all, search behavior is changing very fast. And now every recommendation engine, they are asking themselves like, whether user is really interested in results, seeing more papers, more articles, or they are just looking for an answer, right? They have a question in mind, and for that they used to go through different results earlier. But can we get them directly to the answers now without actually going through uh, papers, right, in a sequential way? So these are the lessons that or experiences that I have had with the past project, which I am trying to, use in this project. So, so far, do you have any thoughts, any doubts around this?
Yeah, Ankush, I have no doubts. I wanted to ask like a couple of questions. I don't know if you will cover them further, but so when you start with PDFs, how do you sort of pre-process them? Like, do you convert them to text and then just work with the raw text files, or are you using something like a document understanding model which tells you that this is the introduction part of it and this is the abstract part of it, something like that?
So that's a very good question. I'll definitely cover that. Like it's a key component of our system, and I'll be covering the key components soon in the coming slides.
Okay.
Okay. But long story short, we are using a PDF parser that takes in as PDF and gives the structured output, text output like JSON output, and then we leverage it for further pipelines. So coming back to it, like what is the inspiration of this project, right? So one is past experience, another is like how we want to take it forward, right? So one is like what are the principles that this project will be built upon. So I am a very avid user of Obsidian MD. This is a note keeping app, and basically I have copy pasted these principles, like I align with them strongly, and this is my vision for this project, right? So the principles are yours: durable, private, malleable, independent. Okay. So one thing is that the data that you put in the app, it belongs to yours, to you, right? Product should not have much to do with your data more than it is necessary, right? So that is the first principle, that your data should remain yours. Second thing is durable. Uh, every product has a shelf life. Like no product lives forever, but the work that you do on the product, it's your life work, and it should not just go away with the product, right? So you should be able to, so even if the product doesn't live long or live forever, the data that should you have, that you produce on the app, it should stay with you as long as you want, right? So that is the principle around durable. Third thing is private. Product should not poke nose on whatever you are doing and all that. So that's the privacy part. Fourth part is malleable. Malleable means you should be able to add any capabilities that you want. The product should fit in your workflow neatly, rather than trying to mold your workflow as per its own design choices, right? So uh, for example, in Obsidian, what happens is that it has some core components, and then there are like community built plugins which you can assimilate in your note keeping app, right? So that allows you to actually develop something for yourself and also share with the community. And the product doesn't say much about how you should manage your workflow. So that is about malleability part. The product should be malleable. Fifth part is independent. So independent is like currently it's a little far-fetched, but I'll explain to you anyways. Independent here means that product should be driven by a community, by users, let's say later on paying users, instead of VC money, and inviting all the decisions that comes when you take VC money for development, right? uh, it's not necessary that VC money is bad. Some people definitely need that for fast growth, but the fifth point here says that we can delegate. We can postpone it as much as possible as long as it is sustainable by the community. Okay, so this is the vision for this project. Uh, Now let's go into the technical details of the project. So there are some core components of the projects. So one is PDF parser. The PDFs that you have on your system, they are like in PDF format, and the text in it is not directly available. So we use an open source service called Grobit. So Growbit can be downloaded on your local machine. You give it the PDF and it gives you a structured output of that PDF. So we'll look into, I'll just run it quickly on the notebook and you'll see what kind of output it gets, right? So second thing is database. So since it is a local first app, everything here is on your local, except with a few exceptions. So Growbit service is going to be installed on your local machine once you uh, build this project on your machine. Database, we need database to store the extracted text that comes out of PDFs. Also user interaction. Let's say you ask multiple questions on the platform. That chat history, all the interactions that you need that needs to be stored, so that you have access to the history. You can revisit it again and again. So that's what database is for, and we use MySQLite for that. It's a file-based database, not much overhead of a service or something like that. Right? Third thing is search engine for retrieval. So to do question answering, we need a vector database, and we have currently gone for Quadrant. So Quadrant takes in as your text, and it allows you to store vectors for that, and that makes it easier for you to answer questions that don't have an exact match in your PDFs, but you are able to still get results. So Quadrant is our vector database. We are using LLM for QA, and currently we have support for OpenAI, Mistral, Vertex APIs. So if you have API key for any of these, you can just set them in your settings, and that becomes your default question answering LLM. But our goal is to get this also in local. So if we can run an LLM, local LLM support is in our to-do list, definitely. So we'll share that update with you also, like soon. So before going to the future map, roadmap, let me just get you to the notebook that I had, like when I was starting this project. So basically, we have a PDF. Okay, so let's say that I want to operate on this PDF, right? So first I need to parse it. So I have a Growbit service running directly on this path. Okay, I'll pass this PDF to that, and I'll see what is the parse content. Okay, so let me run this quickly. XML today. Okay. Okay. This file. Let me copy some other file and we can check on that. So let's graph text rank. So yeah, It took 1 second to parse this PDF, and now we can look at what the article content looks like, right? Uh, so what it returns is basically a big JSON file where I have these different fields. Okay, uh, abstract is where my abstract will go. Then I have sections. So what sections are basically all the headings of the paper. Based on that, we will have different sections, and in sections also the data will be divided based on paragraphs. Okay, then we have citations. So all the references that we have at the end of the paper, all that goes into as a list in this. We have keywords if the paper have keywords, and in bibliography, basically title, authors, all that information goes. So let me run this and see what one sections look like. So every a section is basically a list. Okay, and in that we have paragraphs, and each paragraph looks like this. So it has text, it has a start and end, like in the section when does it start, when where does it end. Okay, and it also has references. So let's say that if this paragraph has some inline citations, then it also gives us a dictionary, and it maps it to the that citation. So not only have you have paragraph text, but you also have all the inline citations mapped to it. Wherever these inline citations helps us in looking up more data. So let's say that uh, this ends up being the context of my RAG pipeline, right? Then if I want, I can also look this paper in the internet, through some agent based system, and also use that to answer the question, right? So once we have all the article content, then we have to index it, right? So this is our literature collection in the quadrant. So I won't run it, so it will like corrupt my data, but definitely I can show you in the quadrant like what does this data looks like. So in order to store the paper content in vector database, we use chunking, and we use chunking paragraph wise. So we don't want chunks to overlap between paragraphs. This is based on the assumption that each paragraph will contain one idea. So our chunks are well within the same paragraph. Okay, they don't overlap across uh, paragraphs. We use LangChain for this, and once like so this is like how our vectors are indexed. What vectors, what model we use? We use sparse vectors. So sparse vector is a recent phenomena where we use best of both worlds. We don't exactly use the dense embedding also, but we also introduce the neural aspect of language modeling. Okay, so let me give you a quick overview of sparse vectors. So let's say that I have a query, okay, and I want documents related to that. So earlier what we used to do is we used to expand that query, and we used to use the synonyms of that query words. Okay, and we used to get the synonym content also, although it was not in the original query. This thing is called query expansion. Now what sparse vector does is basically they also do query expansion, but rather than using synonyms, they actually use a neural language model, and they pick high probability words generated by that language model. So, as we discussed earlier, also in language modeling, what next word prediction does is it gives us a distribution of around a vocabulary, that what are the probability of a word occurring there, right? Now imagine that we pick high probability words out of it, right, and use them for query expansion. Now what happens is that we have moved beyond just synonyms. We are able to bring the right contextual words using a neural model while leveraging the Leucine based indexing. Okay, so it's kind of best of both worlds. So that's what sparse vector is about. We are using them initially, and once we have this, we index the query also and document also using sparse vectors. So each document look like this, and we can see that our vector is like here of 86 length, another is of 178 length. So dense vector has to have same embedding for all the vectors. Sparse vector doesn't need to have. What it means is basically when we ran this through our language model, 178 tokens came out of the context, which is like high, which was coming out of the probability distribution of that language model. So larger the text, larger the context that is going to come out of it. So it is suggested that we use sparse indexes for short length. So once we have the index, we index the query, we generate vector for query also, and then we search based on that query. Let me just do it. So collection name. So we'll see that here. Yeah, literature collection has been taken, and all the vectors has been indexed over there. Here now we can just see how it goes. So paragraphs have been indexed. Now we want context documents, right? So this is our function. What it does is basically it takes a query text, and then it generates the vector using the compute vector function, which based on a model generates vectors. Okay. Uh, our expanded query looks something like this. So we can run it. Okay, so this is a function that given a query text gets the document out of our corpus based on vector search. Okay, so we frame vector out of query and then use that vector to get the matching results. So this is what this function do. And once we get the context documents, this is how our prompt looks like to LLM. Okay, so this is our context basically. We say that if you don't know the answer, just say no, but don't try to make up the answer. Okay, and we explicitly say that we want you to use the passages and chat history to answer the user question. Okay, this is something our prompts look like. Here all the context document that came from vector search comes in. Here is our question. Okay, and we run it. So now I want to talk to the LLM, okay? And let's say that my query text is how does text triangle algorithm work? So it used to work in my collection, but I'll use something. Yeah, it should work because this is the paper that we index, right? So when I do that, my index looks something like this. My query looks something like this, okay? So this expanded to this. So this is the query expansion of this. So you can see the words being broken. So that's the tokenizer in action. And you see that out of algorithm, there are different words coming up: mechanism, method, okay, equation, text rank, out of text rank, rank, ranked, algorithm, computer, right? So these are the words that are coming out of this query. Now this vector is what we use, and then we get this answer. Okay, the text rank algorithm works by building this, and it is also telling us the sources, like which paragraphs contains this answer. Okay, so this is a rough dry run. You can definitely fork this repo and run this notebook for your PDF and see it in action. Okay, So this was about the technical details. Do you have any question over here? I'm sorry, I'm rushing a bit. We are running short of time, but
No, no, Ankush, bhai, it's clear.
okay. Cool. So this is like so. Likewise, I have different notebooks for different features that I have thought of. So let me have a quick look at this also. So this is basically applying text rank on the citation graph of your literature. Okay, so what it returns is basically what are the highly influential papers that you have in your repo based on how many papers are citing them. Okay, so you can see this neural probabilistic language model. It is cited by almost everyone who is working on language modeling. Okay, so yeah, please feel free to run it and see it in action. uh, I'll go to the future roadmap, right? So currently we support uh, quadrant, right? But we want to be as flexible as possible so that we can support multiple vector databases. Someone want to use, let's say, Elasticsearch, plain text search for the retrieval. We should be able to do that. If someone wants to use VB8 or some solution like that, we should be able to support that. Second part is entity linking. Basically, we want to every PDF have different concepts, right? So page rank is a concept, text rank is a concept, right? And these concepts have their entry in Wikipedia. So can we link that and provide it in the Q&A format or something like that? So currently, if you can see here, what I am giving is basically the file path, right? And snippet from where I might have gotten the answer. But can I give the Wikipedia link of all the concepts that are occurring, right? That makes it easier for user to even look up Wikipedia. And in a more advanced form, can I actually use the Wikipedia content also to answer questions? So that falls into entity linking. Second thing is, can I link papers to DOI? So every paper has a DOI, and once we have a DOI, we can actually pull a lot of information like their citations, their references, by using third-party APIs like you know Crossref or OpenAlex. These are the different API providers, like on research paper data, free APIs. Uh, Obviously, they have some usage quota, but for a single user, you can actually fire them and get results. Another thing is citation graph and navigation. So can I create a citation graph and have a holistic view of how the field is evolving, how things led to one idea, right? Can I zoom in? Can I download that paper, that node, right? So that is something we have in mind. Another thing is mind maps. So I recently came across something like, you know, an experiment done on Gamma. So what it does is basically it takes text and then generate mind map for that. So imagine if we can do that for a research papers, right? It will be very useful for people to retain information that they are consuming while reading research paper. Another thing, like there are a lot of ideas, but these are like just to name a few. Imagine that you want to make a presentation on a research paper, right? And you want to present that paper. Can you just type the headings of the slides and then ask, LLM to generate the content of the slide so that you can review, whether it makes sense. So there are a lot of use cases that are possible over here, but one by one. So currently the state of project is it's open for developers. I'll share this here also. uh, Please feel free to forget. Okay, so currently there are three kind of tracks or contribution that we are looking at. A UI development is in React. So if you are a React developer, or you know someone who wants some open source action, please feel free to share this repo with them. Another is backend development. So the API, how it's exposed, so we use Python, Flask, SQLite for backend development. And then there are like LLM action, you know, where we have graphs, citation graphs, vector DBs, how to interact with LLMs, how to build RAGs, right? All those things are like we have that kind of action in store. So yeah, please feel free to fork it and try it on your own. If you have some ideas, please feel to raise an issue and we can definitely discuss. So currently we have a product roadmap over here. This is what it looks like. If you have some ideas, definitely we can open a discussion and move them over here. So for example, we have like you want to show chat history in the QA page, whatever questions user have asked before, entity linking, just like we discussed, DOI resolution. Currently, we support third-party APIs like OpenAI and Mistral. But what if you want to host a local LM, right? And the advanced version of it is like, what if I want to train that local model based on corrections? So let's say it is giving me some answer, and I am able to select some stanza that okay, this is where the right answer is, right? Can I train that over time? So yeah, this is what it looks like. It's a very young project, I think 1 month old. So I thought I should uh, share it with you all here. So yeah, please fork it on your local, run it on your local, the notebooks that you have, write your own notebooks on the experiments. If you see any bug or documentation is not clear, please feel free to report bug in the issues. Any ideas, feature requests that you have, please feel free to reach out. So yeah, thank you.
Yeah. Thank you, Ankush bhai.
Well, they've got things going again.
So that brings us to the end of this session. Thank you all for taking time on weekend for this talk, and I'll mail you the all the links that we have. We'll share the notebooks also with you. Please feel free to try out and read back to us in case of any doubt. Okay. Thanks all. Have a nice weekend. Bye bye.
Bye. Bye bye.